Hey guys, this is homework 7.14 on solving rational inequalities. We're going to go through two examples together. One thing I want you to notice is now we have an inequality symbol instead of an equal sign. Also, this is set up as a fraction. That's usually what we call rational expressions. So the first thing that we're actually going to do is find out what the critical values are. What I mean by critical values is really just the undefined values. So I'm going to do that by setting the denominator, any denominator that has a variable in it, equal to 0. In this specific inequality, only the left side has a denominator that has variables in it. So I'm going to set that x squared minus 6x plus 9 equal to 0. Figure out what those critical values are. So I'm going to factor this out. And I get x minus 3 equals 0. So that makes my critical value x equals 3. I'm going to keep this here because that's going to be important for us to come back to in a little bit. So what I'm going to do next is I'm going to take my original inequality and I'm first going to change the inequality symbol to an equal sign. So I'm going to rewrite it so that the inequality sign is an equal sign instead. If you remember when we have solved inequalities in the past, we did the same thing. We just changed the inequality sign to an equal sign. We'll bring it back later. We're not totally going to forget about it. The next thing I'm going to do is, since I see on the right side of the equation it just says 0, I'm just going to put that 0 over 1, and now I'm going to cross multiply. So when I cross multiply, I get x squared plus 3x minus 4 equals 0, because this x squared minus 6x plus 9 actually times 0 just gives us 0. So now actually this isn't so bad. Now I'm going to factor that x squared plus 3x minus 4. So when I factor this, I need two numbers that add to 3 while also multiplying to negative 4. So I'm going to need 4 and 1, and the 4 should be positive, the 1 should be negative. So now when I set each of these equal to 0, I get x equals negative 4 and x equals 1. Okay, so now you see I have three different values for x here. I have my critical value, x equals 3, and then I have these two values, x equals negative 4 and x equals 1. What I'm going to do now is I'm going to create a number line, and this number line is going to help us bring back the inequality. So let's do that. Okay, on my number line, I want to plot. Okay, so I'm going to plot my negative 4, my 1, and my 3. And I am going to put a closed circle over the 3 because that's a critical value. So that always gets a closed circle because I know that I cannot use that number in my solution set. That number will not work. It will make the bottom of the fraction 0, which makes it undefined. And then for these two values, the negative 4 and the 1, we determined whether to use an open or closed circle by the original equation. And the original equation was just a less than sign. It was not or equal to. So we're going to use an open circle over those as well. The critical value, though, always gets an open circle no matter what. Okay, so now you can see that this number line is broken up into 1, 2, 3, 4 different sections. So what we're going to do is take a test point from each of those 4 sections, and we're going to see if it works. So from the first section, I'm going to use the test point x is negative 5. From the second section, I'm going to use the test point, it has to be between negative 4 and 1. So I will just use the test point 0. That's always nice and easy. From the third section, between 1 and 3, I'll use the test point x equals 2. And from the fourth section, anything greater than 3, I'll use the test point x equals 4. So I'm going to plug these back into the original equation. So just to remind you, I'll write the original equation on the side. The original equation was x squared plus 3x minus 4 all over x squared minus 6x plus 9 is less than 0. So now there is a little bit of a shortcut here. What you can do is you can plug in the equation, specifically the left side of the equation, into your calculator, and see when x is -5 what you get. And then you can compare if that is, in fact, less than 0 or not. So we can use our calculator to help us here. Okay, so again, you can do the algebra by hand and actually physically plug in -5 into all the x's and simplify. Or you can use your calculator to help you simplify. Or you can use the y equals, plug the equation in, and look at the table. So I'm going to just tell you kind of what I got for each thing. So when I did plug in -5 for all the x's, for the first section, I ended up getting 3/2 for the left side of the equation. So 3/2 is less than 0. So I asked myself, is that true or not? 3/2 is definitely more than 0. So this is not true. So that means there will not be any shading in section 1. X equals 0. So what I ended up getting there was -4/9 is less than 0. Because I got -4/9 when I plugged in 0 on the left side of the equation. This is true, so that means there will be shading in section 2, so I'm going to go ahead and shade right there. Okay, then for section 3, when I plugged in x equals 2, I got 6/1 is less than 0. That's not true, so there will not be any shading in section 3. And then the last section, section 4, x equals 4. When I plug that in, I got -24/3. And I just see right off the bat it's a negative number. So this number is less than 0. That is true. So there will be shading in section 4. Okay, so I have this number line where I have shading in between -4 and 1, and then for everything greater than 3. So the last thing I need to do here is I need to express my answer. It may specify whether to express it in set builder notation or interval notation. So just for the sake of it, I'll just show you both. Okay, so I am going to rearrange a few things here to make some space for myself. I'm just going to move all this down. Now I can see my number line. Okay, so let's do first, we'll do set builder notation. Set builder. Set builder notation really just means when you start out with the little squigglies, and then you say x such that, and then we use an inequality within the set. So I need to use actually 2 different inequalities, because I need to express that x is between -4 and 1, so that's going to be for this guy, and then that x is greater than 3. Notice there is no little extra line underneath my inequality symbols because it's not equal to any of these numbers. Okay, so that's exactly what I'm going to write. I'm going to write -4 is less than x, which is less than 1, and also x is greater than 3, and that's it. So this is my set builder notation. I don't need to say anywhere x cannot be 3, even though 3 is our critical value, because this is doing that for me. Me indicating that x is greater than 3 means that it can't be equal to 3. Okay, and then interval notation, that's when we use the parentheses or the hard brackets. So here, to express between -4 and 1, I would use the soft brackets, and I would do -4 to 1. And then for over here, from 3 and on, I would do 3 to positive infinity. And again, soft brackets. And then I would use the word or, because we can't have a number that fits both of those descriptions. So this would be interval notation. Okay, let's go on to example number 2. Before we go on to example number 2, let's just do a quick recap of all the steps that we took. First thing we did was we found the critical values, which is just known as the undefined values. We did that by setting any denominators that have variables in them equal to 0. Second thing we did is we changed the inequality to an equal sign. This is an important step because if you don't do this, then you're going to get confused by the inequality sign. The third thing we did was we solved for the variable. After that, we then drew a number line and plotted all the values, including the critical values. And then the last thing we did was we determined where the shading is by using test points, and then we expressed our answer as a solution set. Okay, I think now we're ready for example 2. Okay, so here is example 2. So I'm going to start out just like the last one, and I'm going to first find my critical values. So I see the left side of the equation has a denominator which has variables in it. So I'm going to set that denominator equal to 0, and that's going to tell me my critical values. So I subtract 3 from both sides, and then I'm going to divide by 2. X equals -3/2. Okay, so this is my one and only critical value. The next thing I'm going to do is I'm going to rewrite this by changing the inequality sign to an equal sign. And I'm also going to put this 2 over 1, so that makes it easier for me to cross multiply. So now when I cross multiply, I get 4x times 1, which is just 4x, and then 2 times 2x plus 3. Okay, now I am going to distribute on the right side of my equation, and I get 4x plus 6. Okay, and then I'm going to try to get the x's to one side, so I'm going to subtract 4x. So, hopefully you notice here there's a little bit of a dilemma. The dilemma is when I do 4x minus 4x, I get 0. 0 equals 6. This is not a true statement. What that means, when I get a statement like this where I'm unable to solve for the variable and it's not a true statement, like 0 equals 6, that means that there are no values that work for this equation. That happens sometimes where there are just no solutions. So what we would write is no solution. If I ended up getting a true statement, like let's say 6 equals 6, that would mean that every value works. That's like when we've talked about polynomial identities. That's like when we get the same thing on both sides, that means any value of x works. That means it's an identity. Okay guys, that's all for this video. If you are unsure of any part of this, make sure that you rewind the video and look over it again. Also, it would be helpful for you to write down those steps that we just talked about in the recap section, so you might want to rewind and write those down. Okay guys, that's all for now.